Noel Joseph Terence Montgomery Needham, CHFRS, FBA, also known as Li Yuese, was a British scientist, historian and sinologist known for his scientific research and writing on the history of Chinese science. He was elected a Fellow of the Royal Society in 1941, and as a Fellow of the British Academy in 1971. Biography. Early years. Needham was the only child of a London family. His father was a doctor and his mother, Alicia Adelaide Neaqt Montgomery, was a musical composer from Oldcastle, Co. Meath, Ireland. Needham was educated at Oundle School before going up to the University of Cambridge, where he earned all his degrees. Bachelor's in 1921, Master's in January 1925, and a doctorate in October 1925. He had intended to study medicine but came under the influence of Frederick Gowland Hopkins and switched to biochemistry. Career after graduation. He was elected to a fellowship at Gonville and Caius College and worked in Hopkins' laboratory at the University Department of Biochemistry, specializing in embryology and morphogenesis. His three-volume work Chemical Embryology, published in 1931, includes a history of embryology from Egyptian times up to the early 19th century, including quotations in most European languages. His Silliman Memorial Lecture of 1936 was published by Yale University under the title of Order and Life. In 1939 he produced a massive work on morphogenesis that a Harvard reviewer claimed will go down in the history of science as Joseph Needham's magnum opus, little knowing what would come later. Although his career as biochemist and an academic was well established, his career developed in unanticipated directions during and after World War II. Three Chinese scientists came to Cambridge for graduate study in 1937. Lu Gui Djen, Wang Yinglai and Shen Shichang. Lu, daughter of a Nanjingese pharmacist, taught Needham Chinese, igniting his interest in China's ancient technological and scientific past. He then pursued, and mastered, the study of classical Chinese privately with Gustav Halloun. Under the Royal Society's direction, Needham was the director of the Sino-British Science Cooperation Office in Chongqing from 1942 to 1946. During this time he made several long journeys through war-torn China and many smaller ones, visiting scientific and educational establishments and obtaining for them much-needed supplies. His longest trip in late 1943 ended in far western Gansu at the caves in Dunhuang at the end of the Great Wall, where the earliest dated printed book, a copy of the Diamond Sutra, was found. The other long trip reached Fuzhou on the east coast, returning across the Xiang River just 2 days before the Japanese blew up the bridge at Hengyang and cut off that part of China. In 1944 he visited Yunnan in an attempt to reach the Burmese border. Everywhere he went he purchased and was given old historical and scientific books which he shipped back to Britain through diplomatic channels and were to form the foundation of his later research. He got to know Zhou Enlai and met numerous Chinese scholars, including the painter Wu Zuorin, and the meteorologist Zhu Kazhen, who later sent crates of books to him in Cambridge, including the 2,000 volumes of the Gujin Tushu Jicheng Encyclopedia, a comprehensive record of China's past. On his return to Europe, he was asked by Julian Huxley to become the first head of the Natural Sciences section of UNESCO in Paris, France. In fact, it was Needham who insisted that science should be included in the organization's mandate at an earlier planning meeting. After 2 years in which the suspicions of the Americans over scientific cooperation with communists intensified, Needham resigned in 1948 and returned to Gonville and Caius College, where he resumed his fellowship and his rooms, which were soon filled with his books. Needham's reputation recovered from the Korean affair such that by 1959 he was elected as president of the Fellows of Caius College, and in 1965 he became master of the college, a post which he held until he was 76. Science and Civilization in China in 1948, Needham proposed a project to the Cambridge University Press for a book on science and civilization in China. Within weeks of it being accepted, the project had grown to 7 volumes and it has expanded ever since. His initial collaborator was the historian Wang Ling, whom he had met in Lijuang and obtained a position for at Trinity. The first years were devoted to compiling a list of every mechanical invention and abstract idea that had been made and conceived in China. These included cast iron, the plowshare, the stirrup, gunpowder, printing, the magnetic compass and clockwork escapements, most of which were thought at the time to be Western inventions. The first volume eventually appeared in 1954. The publication received widespread acclaim, which increased to the lyrical as further volumes appeared. He wrote 15 volumes himself, and the regular production of further volumes continued after his death in 1995. After Volume 3, the volumes were split into parts, and currently 27 volumes have been published. Successive volumes have been published as they became ready, which means that they have not appeared in the order originally contemplated in the project's prospectus. Needham's Final Organizing Schema, Volume I, Introductory Orientations, Volume 2, History of Scientific Thought, Volume 3, Mathematics and the Sciences of the Heavens and Earth, Volume IV, Physics and Physical Technology, Volume V, Chemistry and Chemical Technology, Volume VI, Biology and Biological Technology, Volume 7, The Social Background. See Science and Civilization in China for a full list. The project is still proceeding under the guidance of the Publications Board of the Needham Research Institute, chaired by Christopher Cullen. Needham Question. Needham's Grand Question, also known as the Needham Question, is why China and India had been overtaken by the West in science and technology, despite their earlier successes. Why did modern science, the mathematization of hypotheses about nature, with all its implications for advanced technology, take its meteoric rise only in the West at the time of Galileo, but had not developed in Chinese civilization or Indian civilization? Gunpowder, the magnetic compass, and paper and printing, which Francis Bacon considered as the 3 most important inventions facilitating the West's transformation from the Dark Ages to the modern world, were invented in China. Needham's works attribute significant weight to the impact of Confucianism and Taoism on the pace of Chinese scientific discovery, and emphasizes what it describes as the diffusionist approach to Chinese science as opposed to a perceived independent inventiveness in the Western world. Needham held that the notion that the Chinese script had inhibited scientific thought was grossly overrated. His own research revealed a steady accumulation of scientific results throughout Chinese history. In the final volume, he suggests a continuing general and scientific progress manifested itself in traditional Chinese society, but this was violently overtaken by the exponential growth of modern science after the Renaissance in Europe. China was homeostatic, but never stagnant. Nathan Sivan, one of Needham's collaborators, while agreeing that Needham's achievement was monumental, suggested that the Needham question, as a counterfactual hypothesis, was not conducive to a useful answer. It is striking that this question, why didn't the Chinese beat Europeans to the scientific revolution, happens to be one of the few questions that people often ask in public places about why something didn't happen in history. It is analogous to the question of why your name did not appear on page 3 of today's newspaper. There are several hypotheses attempting to explain the Needham question. Yingqi Liu and Chunjiang Liu argued that the issue rested on the lack of property rights and that those rights were only obtainable through favor of the emperor. Protection was incomplete as the emperor can rescind those rights at any time. Science and technology was subjugated to the needs of the feudal royal family, and any new discoveries were sequestered by the government for its use. The government took steps to control and interfere with private enterprises by manipulating prices and partaking in bribery. Each revolution in China redistributed property rights under the same feudal system. Land and property were reallocated first and foremost to the royal family of the new dynasty up until the late Qing dynasty, when fiefdom land was taken over by warlords and merchants. These limited property rights held back much of the potential scientific innovations of that time. The Chinese Empire enacted totalitarian control and was able to do so because of its great size. There were smaller independent states that had no choice but to comply with this control. They could not afford to isolate themselves. The Chinese believed in the well-being of the state as their primary motive for economic activity, and individual initiatives were shunned. There were regulations on the press, clothing, construction, music, birth rates, and trade. The Chinese state controlled all aspects of life, severely limiting any incentives to innovate and to better oneself. The ingenuity and inventiveness of the Chinese would no doubt have enriched China further and probably brought it to the threshold of modern industry. Had it not been for this stifling state control, it is the state that killed technological progress in China. According to Justin Lin, China did not make the shift from an experience-based technological invention process to an experiment-based innovation process. The experience-based process depended on the size of a population. And while new technologies have come about through the trials and errors of the peasants and artisans, experiment-based processes surpasses experience-based processes in yielding new technology. Progress from experimentation following the logic of a scientific method can occur at a much faster rate because the inventor can perform many trials during the same production period under a controlled environment. Results from experimentation is dependent on the stock of scientific knowledge, while results from experience-based processes is tied directly to the size of a population. Hence, experiment-based innovation processes have a higher likelihood of producing better technology as human capital grows. China had about twice the population of Europe up until the 13th century and so had a higher probability of creating new technologies. After the 14th century, China's population grew exponentially, but progress in innovation saw diminishing returns. Europe had a smaller population but began to integrate science and technology that arose from the scientific revolution in the 17th century. This scientific revolution gave Europe a comparative advantage in developing technology in modern times. Ling blamed the institutions in China for preventing the adoption of the experiment-based methodology. Its socio-political institution inhibited intellectual creativity, but more importantly, it diverted this creativity away from scientific endeavors. Totalitarian control by the state in the Chinese Empire inhibited public dispute, competition, and the growth of modern science, while the clusters of independent European nations were more favorable to competition and scientific development. In addition, the Chinese did not have the incentives to acquire human capital necessary for modern scientific experimentation. Civil service was deemed the most rewarding and honorable work in pre-modern China. The gifted had more incentives to pursue this route to move up the social status ladder as opposed to pursuing scientific endeavors. Evaluations and critiques. Needham's work has been criticized by some scholars who assert that it has a strong inclination to exaggerate Chinese technological achievements and has an excessive propensity to assume a Chinese origin for the wide range of objects his work covered. Pierre-Yves Manguin writes, for instance, J. Needham's monumental work on Chinese nautics offers by far the most scholarly synthesis on the subjects of Chinese shipbuilding and navigation. His propensity to view the Chinese as the initiators of all things and his constant references to the superiority of Chinese over the rest of the world's techniques does at times detract from his argument. Referring to Needham's work as a sinologist, the essay on Meng Shi by Tan's World of Marginalities in South Pointing Needles, Fragment translation versus contextual tradition by Dai Weifu, published in De l'Anneau multiple traductions du chinois vers les langues européennes, which argues for contextual translations instead of fragmented ones, criticizes Needham political involvement. Needham's political views were unorthodox and his lifestyle controversial. His left-wing stance was based in an idiosyncratic form of Christian socialism, and after 1949 his sympathy with Chinese culture was extended to the new government. During his stay in China, Needham was asked to analyze some cattle cakes which the Communists claimed had been scattered by American aircraft in the south of China at the end of World War II, and found they were impregnated with anthrax. During the Korean War, further accusations were made that the Americans had used biological warfare. Zhou Enlai coordinated an international campaign to enlist Needham for a study commission, tacitly offering access to materials and contacts in China needed for his then early research. Needham agreed to be an inspector in North Korea, and his report supported the allegations. After post-Cold War revelations that the Soviets had assisted the Chinese in setting up false scenarios, Needham's biographer Simon Winchester commented that Needham was intellectually in love with communism, and yet communist spymasters and agents, it turned out, had pitilessly duped him. Needham was blacklisted by the U.S. government until well into the 1970s. In 1965, with Derek Bryan, a retired diplomat whom he first met in China, Needham established the Society for Anglo-Chinese Understanding, which for some years provided the only way for the British to visit the People's Republic of China. On a visit to China in 1964 he was met by Zhou Enlai, but on a visit in 1972 he was deeply depressed by the changes under the Cultural Revolution. Personal life: Needham was married to the biochemist Dorothy Moyle in 1924, and they became the first husband and wife both to be elected as Fellows of the Royal Society. Simon Winchester notes that, in his younger days, Needham was an avid gymnosophist and he was always attracted by pretty women. When he and Lu Guidjen met in 1937, they fell deeply in love, which Dorothy accepted. The three of them eventually lived contentedly on the same road in Cambridge for many years. In 1989, 2 years after Dorothy's death, Needham married Lu, who died 2 years later. He suffered from Parkinson's disease from 1982, and died at the age of 94 at his Cambridge home. In 2008, the chair of Chinese in the University of Cambridge, a post never awarded to Needham, was endowed in his honor as the Joseph Needham Professorship of Chinese History, Science and Civilization. Needham was a High Church Anglo-Catholic who worshipped regularly at Ely Cathedral and in the college chapel, but he also described himself as an honorary Taoist. Honors and awards. In 1961, Needham was awarded the George Sarton Medal by the History of Science Society, and in 1966 he became Master of Gonville and Caius College. In 1984, Needham became the fourth recipient of the J.D. Bernal Award, awarded by the Society for Social Studies of Science. In 1990, he was awarded the Fukuoka Asian Culture Prize by Fukuoka City. The Needham Research Institute, devoted to the study of China's scientific history, was opened in 1985 by Prince Philip, Duke of Edinburgh. Order of the Companions of Honour, 1992. British Academy, 1971. Royal Society, 1941. Offices held. Bibliography. Science, Religion and Reality. Man and Machine. Kegan Paul. Chemical Embryology. CUP. The Great Amphibium. 4 lectures on the position of religion in a world dominated by science. A History of Embryology. CUP. Order and Life. The Terry Lectures. Biochemistry and Morphogenesis. Time. The Refreshing River. Chinese Science Pilot Press. History is on our side. Science Outpost, Papiers of the Sino-British Science Cooperation Office 1942–1946 Pilot Press. Science and Civilization in China CUP. 27 volumes to date. The Grand Titration. Science and Society in East and West Allen and Unwin. Within the Four Seas. The Dialogue of East and West. Clerks and Craftsmen in China and the West. Lectures and Addresses on the History of Science and Technology CUP. Chinese Science. Explorations of an Ancient Tradition ed. Shigeru Nakayama, Nathan Sivan. Cambridge. MIT Press. Molds of Understanding. A Pattern of Natural Philosophy Allen and Unwin. The Shorter Science and Civilization in China, an abridgment by Colin Ronan. Science in Traditional China. A Comparative Perspective. The Genius of China, a one-volume distillation by Robert Temple Simon and Schuster. Heavenly Clockwork. The Great Astronomical Clocks of Medieval China CUP. The Hall of Heavenly Records. Korean Astronomical Instruments and Clocks, 1380–1780, CUP. A selection from the writings of Joseph Needham, Ed Mansell Davies, The Book Guild 1990.